So hello everyone, welcome. I'm very happy to be here face to face after so many years. We're going to talk today about API security. I think that we cannot really discuss APIs without considering security. This is correct for every single thing in software, but we're here to discuss APIs, so let's do that. How many of you are aware of OWASP as an organization? Oh, awesome, that's really good. So I guess we can start. Let's start with a question. What do all these logos have in common? So actually I stopped updating this slide, I think almost a year ago when I ran out of space, but last year each and every one of those had some sort of either an exploit, vulnerability found, anything that went wrong with their APIs. And basically, I'm not here to name names and point fingers, but some of these logos are the best of the best that we have today. So if they still fall down in the traps of APIs, then we all might be in the same place. So let's start. My name is Erez. I'm a VP of Security Research at Checkmarx. And the rest of the bullets you can read in my bio, but what you cannot read in my bio is that I have a superpower. And this special superpower is that I am exposed to many mistakes. I see so many mistakes all day long, from morning to evening, thousands of customers, thousands of millions of lines of codes and projects. And I'm going to share with you a trend that will not surprise you one bit. The biggest problems in security are those of the latest technology. I don't think I'm saying anything here that does not make sense, but these days where everything is about APIs, it's not even a question anymore. Modern application, modern software is around APIs, period. So we see a lot of issues and a lot of problems around that. So when I'm talking about API security, I want to remind you that what I'm actually saying, I'm not securing the APIs, but I'm securing the entire software. We're talking about the security of API-based apps, which is literally modern application security, or every software these days. So what makes APIs vulnerable? Let's talk about three main reasons that we see. The first one is the abundance of API endpoints that make the attack surface bigger. If we're looking at a traditional or monolith application, basically, the entry point for a user and a malicious attacker would be the same one. They would have to go through A and then flow through the logic of the application to B and C until they get what they want. These days, the picture is completely different. We have different components in API-based applications, and although we expect the users to start from A, there is no reason for an attacker not to go through B or C, or what the hell, why not go to H? I mean, there is nothing actually limiting us when it's all open. So this is the first thing. The second thing is that clients consume raw data. And we see all kinds of things, all this data flowing in the air, and we'll talk about it a bit later. In each HTTP request, we see IDs and values and filters. And although in this specific example, for example, a component one, maybe they trust component 2 and 4, but what happens when component 2 gets the information from component 3? Or maybe sends some information to component 3? Was component 1 aware of that? Usually the answer is no. But we see that a lot. And the last thing is actually the byproduct of the flexibility of CI/CD processes these days. We see effortless deployment of microservices and containers, cloud infrastructure, everything like that. It takes really a few clicks to deploy and spin up a new API host. And it's so easy that it's almost too easy. And why is it a problem? Because the rate of updates and changes, it really does not allow us to handle that in a fast enough way. And APIs become hard to track. We see shadow APIs or orphan APIs. We see old exposed APIs. And basically, we don't really know what we have anymore. And we're not talking about a few or dozens. We're talking about sometimes hundreds and even thousands of APIs that are just floating in the space waiting for someone to find them, and it's not necessarily going to be the right person that will find them. So how do we bridge the gap? In 2019, Inon Shkedi and myself started an OWASP project called the API Security Project. And the idea behind it was to try and make sure that developers who are usually more, know more about the OWASP Top 10, the regular one, which kind of caters more towards the traditional applications, will have visibility into API security. So this is the list. To make it easier down your throat, we're going to divide it into 4 categories. So let's start with them. The first category is the one we stole from the OWASP Top 10. We stole injection and we stole insufficient logging and monitoring. Let's talk about that. Injection we put in number 8, although that in the OWASP, the regular OWASP Top 10, it's in the first place. We believe that SQL injections are not very common in modern APIs, and there are several reasons for that. One is the use of ORMs, and there is an increasing use of NoSQL. And I know someone is now moving here uncomfortably saying, wait, there is something called NoSQL injections, and you are correct, it is a thing, but they're usually not that common and usually not that severe. Regarding the API 10, which is insufficient logging and monitoring, again, this is not something that makes your code vulnerable, but it is something that increases the risk. And this is correct for every piece of software. Exploitation of insufficient logging and monitoring is something that makes every attack successful, basically. So attackers rely on that, and we want to make sure that we take care of that, no matter if we're using APIs or not. So we put these 2 behind us, injection and insufficient logging and monitoring. Now I need you to be focused, because the next one, the next category is access control. Access control, and basically this is the most important slide of everything. Access control is API security's biggest challenge. This is an unsolved challenge. Please solve it. In this family, we have these 3 categories. You can see that 3 of the top 5 are in the access control family. So the first one is broken object level authorization, broken authentication, and broken function level authorization. Let's start with broken authentication. So broken authentication is something that comes because we are lacking protection or we are misimplementing protection. Let's see an example. So we have a set of APIs here, and you can see that there are several types of them, and we expect all of them to be protected. But here in yellow, there are 3 APIs that are specifically handling logins. And basically, logins are access control, and we expect to have extra protection around these ones. And when I talk about extra protection, it can be anything from CAPTCHA and multi-factor authentication, account lockout mechanism. We see many types of protections around brute force and credential stuffing and password spraying. All these things must be implemented when we are talking about API endpoints that are handling access control. Obviously, there is a way to shoot our own foot, even if we do that, so we can sometimes misimplement several mechanisms of doing that. The most famous one is using JWT algorithms with no algorithm in it, basically, or no validation of authentication provider. So basically, someone can authenticate themselves. Passwords that are stored without salt. Again, not specifically something about APIs, but yes, we can look around everything and then forget that part. This is a misimplementation and causes broken authentication. And there are many more ways. Why is it so common, specifically in APIs? Authentication endpoints are exposed to anyone by design. We don't need to look for them. They are there because we are expecting others to use them. There are many misconceptions around them. I showed the the JWT one, for example, but we see a lot of uses of API keys that are used as users' authentication. We see a lot of confusion between authorization and authentication. These are things that are with us for years now, and still these are the top confusions we see. Also, multiple authentications in modern applications. You have a specific way from IoT, you have the ones from mobile, obviously you need legacy, and God forbid you also have some deep links with credentials still working somewhere. So this is just all over the place. Let's move toward authorization. We split authorization into object level and function level. Let's talk about the broken object level authorization, or the way we like to call it, BOLA. So the right way to do things is if a user is trying to access their object, in this case, some sort of document, and gets access, and that's fine. If the same user is trying to get to another object, which is not theirs to be accessed, then they're supposed to get no. Very simple to define. If we don't have that, we have BOLA. We have broken object level authorization. And that happens a lot. Why is it so common in API? So you remember that the attack surface is much wider. We must make sure that every place that an attacker can come in is somehow governed by that mechanism. Also, there is just no security solution that solves the problem. There is no silver bullet for that. This is something that comes from the get-go. When we start threat modeling, when we start architecture, this needs to start from the first line of code. And the last member in this family is broken function level authorization. It's similar to object level, but here we're not talking about what I can access, but how or what I can do with it. So broken function level authorization, or as we call it, BFLA, you don't have to. If you would speak Hebrew, you would find it funny, but you don't. You can come to me after this. So basically, things that works well looks like this. We have an admin, we have a regular user, and we have different levels or different types of APIs. So in a normal scenario, both admin and regular user can access public API. For example, here we see a GET, and get the results, and everything is fine. Also, in the same API that works well, or authorization mechanism that works well, an admin can access an admin API. For example, in this case, we want to delete a user, and they are supposed to be able to do that. But a regular user is not supposed to do that. So again, the definition is very, very clear. It's very, very easy, but still, we see that issue, we see that BFLA all the time. Why is it so common in APIs? So function level authorization can be implemented in different ways. It can be in the code, it can be in API gateways, configurations, infrastructure, whatnot. When something can be done in many places, where is it done? Nowhere. Or in two different places that may be breaking each other. But yeah, if someone else can do it, they should do it probably. So this is one thing. The second thing is, I think, more interesting for me from an attacker point of view. It's easier to detect an exploit in APIs. The endpoints are predictable. And let's see an example. In a traditional application, if you want to get a user profile or delete a user profile, this is how it would look like. I'm not sure you can see in the back, but basically, if you want to get user profile as a regular endpoint, you just send some sort of GET request. You probably go to a horrible ASPX interface or something and get there. If you want to delete that user, it's possible, and I can guess that, but it's a bit harder. How does it look for me as an attacker today? This is it. The entire difference is the function. I either get or delete. Can I guess that? Yes. Can I super automate that? Of course I can. So we see something that is very hard to predict, or at least harder. And we see something that is very, very easy to predict and to automate. And I think this is the main reason that we are failing with function level authorization a lot. Many times we kind of miss in our minds and we think that objects are documents, and also I gave that example. But this is not that. Object can be anything. This is a research that we did in Checkmarx. Someone thought it makes sense to put a camera, HD camera, by the way, on a robotic vacuum cleaner. Basically, they did not do the access control very well, and we managed to get everything. You can see that the location, live video, even the way that the rooms are built from the inside. So basically, if access control is not done right, you're holding nothing. You have no secrets, no privacy, nothing. We really need to remember that. Let's continue. Are we having fun already? Cool. So, third family. Third family is all about data. Data is moving out, data is moving in, and we're covering both of these categories here. We're talking about excessive data exposure, and we're also talking about mass assignment. Let's break this down. This is Bob, you may know him. Bob is a member in the SuperSafe app, and when a user looks at Bob's profile, they can see his name, role, and hobby. But let's see what happens behind the scenes. So there is a request to get Bob's profile, but if you look at the response, you may see something that maybe you did not really expect to get. You can see Bob's address. Why is that? Why did that happen? And why does regular users don't see that? So what happened here is that someone decided to filter the sensitive data in the application or on the client side. This is always a bad idea, trust me. Why does it happen so much? Why do we have the urge of spreading this extra information with everyone? So actually, this is how languages are built. REST standards encourage developers to implement APIs in a very generic way. Generic is good because everyone can use it. So why not take your entire object, your entire member, and to JSON it? Whatever you have there, someone will take care of the access data. Just send it from the model and without thinking about who's the consumer. Always a mistake. And this is an example. This is not a research by Checkmarx. This is a research by Pentest partners, specifically Alex Lomas, who's here, a member on 3Fun. Of course you don't. 3Fun, for those of you who don't know, it's basically Tinder for those who believe that two are not enough. Okay? I guess this is the way to. So basically, what happened there is the same thing like we saw in Bob's application. There is no way you can see that, but I can tell you that other than the data that the users wanted to share, you can see here the latitude and longitude. You can see the exact age. You can see there are some photos that are not supposed to be, to be shared, sexual preferences, etc. But the most important or the most fun part here is the actual GPS coordinates. And Alex Lomas decided that the right thing is to plot these coordinates on a map of the White House. And managed to get some noise around that. This part is funny, but again, this is something that we see all the time. Let's see the sister of that. Let's see mass assignment. Mass assignment is actually not releasing information, it's getting information. Let's see what may go wrong here. So modern frameworks encourage us to use mass assignment functions. Basically, it's the opposite of toJSON. Okay, we just take a bunch of data and create a user or create something. So here we can see examples from Node.js or Rails or whatever. Just take everything you have in the request, throw it into a new user. Take everything in all the parameters you have, throw it into a new user. And that's okay. But we need to remember that it might contain sensitive parameters that the user should not have access to. And my favorite example, this is a legit request. Bob is opening a new user, so he's using his username Bob and his password. But what if Bob does not use the application but uses, I don't know, the ultra hacking tool Postman or something, and is doing something like that? Now username Bob, password, and he decides on his own role. Suddenly Bob is an admin, unless we notice that. And to be honest, this is happening less and less, but we still see that happening. The last part is the part that is something that we call kind of the category of DevSecOps. DevSecOps is everything around operations. This is the lack of resource and rate limiting, the security misconfigurations, improper assets management. And these are things that are not pleasant to implement, sometimes boring, but they are essential. So if we start with number 4, category 4, lack of resources and rate limiting, I think that we instinctively understand that these days, when a resource, it could be a memory file, access to database, whatever, is exposed to the web, there should be a defined use limit. It can be either the requests, the number, frequency, or the source where it came from. Files need to be kept by size, strings need to be kept by length, and this is something that if we miss or we're not using that, there are dire consequences. The most known one is denial of service. Denial of service is the first thing that we think about around that, but we see more and more something that we call scalping. I mean, we don't call, this is how it's called. You see hundreds of bots going into a store, buying tickets immediately when it opens, just because there is no limit, and then everyone is need to buy from that scalper. This is a bit more around fraud than our traditional application security, but this is something that comes to us a lot now because it becomes more and more popular. Also, brute force attacks, eventually, either by using credential stuffing, password spraying, or just everyday brute force. This is something that is a real danger, and we saw that before. API 7, we kind of cheated. We used kind of a bucket of bad things, security misconfigurations. And the reason is that there is a lot of ways and a lot of areas that we can mess that up. It can be either using weak encryption or no encryption. It can be unnecessarily exposed HTTP methods, sometimes just flipping something as to true or false, as in SSRF protection. Detailed errors. As a person who comes from the attacking side, errors are our friends of the attackers. Please do not underestimate them. And improper course, and I think this list is probably can go on and on, but everything that is around misconfigurations is a problem. The good news here is that we can have a checklist. I mean, not for each and every single thing, but we can have checklist, we can have tests for that. This should be behind us, but not only it's not behind us, it's actually, while other things are getting better, misconfigurations are still getting very high. And I think the last one is improper assets management. This is basically housekeeping. You remember we talked about not knowing what you have. It's common knowledge. You cannot protect what you don't know you have. This is the same here as well. And this can manifest itself in two different ways. Either complete lack of documentation. When you have some sort of payment API, this is a real example that we saw, obviously not the same organization, and everything is very nicely documented except something that is suddenly version 0, who knows what it is, it's legacy, B2B, export all users. I don't know what it's doing. No one knows what it's doing. But it's there, and it's working. And what it causes around, and also other ways of losing track of what you're doing, is to expose risky APIs. And then you have some sort of API gateway protecting your payments and your mobile APIs and everything. But there is something that is not protected. And it's not covered by an API gateway. An API gateway that does not cover everything you have is not really doing a very good job. And again, the users will probably not find it. If your QA or security people will not find it, the attackers will. Why is it so common? And this is painful. APIs change all the time. We know that developers are focused on delivering and not on documenting. We don't like documenting. With cloud and deployment automation, it's way too easy to spin up new APIs and machines. We see that all the time. APIs, hosts that's been forgotten, complete environments that have been forgotten, and this is something very common when you go to the R&D floor in the open space and someone shouts, anyone remembers what is Infra 3 old endpoint doing? I want to check something, or something like that. If you hear something like that in your organization, stop everything and check where you made a bad turn. So this is the top 10 security list that we created by the end of 2019. What happened since then? So let's look moving forward. To be honest, not much changed to our dismay. We thought that we are going to change the world. But what we saw since then. First of all, the OWASP API Top 10 was adopted and quoted by analysis firms like Gartner and Forrester, which is awesome because this is the best way of reaching out to companies that really want to protect themselves. It was also adopted by each and every single API security vendor as something that everyone say that they cover, and that's okay. I'm representing a vendor myself. I'm not going to spit in the well I'm drinking from. But yeah, the API Top 10 is not something, it's not a standard. It's not supposed to be covered by a solution and then you're fine. It's an awareness document. This is something that we need to get in our heads as an education part, as an awareness part, to understand what's going on, to understand why we're losing the fights, and to make sure that our developers are embracing that. Basically, the API Top 10 is the start. It's not the standard. We see more API-related SSRF attacks. I don't want to get deep into that. I'll just give you a quick promo so you can go and do your homework and invest in that. But SSRF, it's a server-side request forgery. Basically, when an attacker cannot really reach a component inside an organization because it's protected in different ways, they always have the option of trying to find an API that can somehow channel him or her inside, and by that leak out information. If they cannot do that and they cannot leak information on the way out, from like it went in to go out, we call it some sort of blind SSRF, and sometimes by injecting some sort of request, we can make this component go and query or send some sort of response to a different server, and this server can be something that the attacker created. Again, this is a bit complicated. This is not really where I want to do that, but if you don't know what SSRF is and you don't want to wait for the next version of the top 10, please go and learn about it. It's very, very interesting, and it's happening a lot and more. So, more API-related SSRF attacks. We see more security incidents of GraphQL and gRPC, which we almost put no effort in the previous list, but the world is really not only REST anymore, and we need to take a look at these areas as well. Access control is still the #1 challenge, and we talked a lot about why, and I hope I managed to convince you. And consumption of API should get some attention. We are always talking about how we basically open our resources and how we let people use our APIs. We also need to talk about the consumption, how we basically attach ourselves to the security of other APIs, of other people, and how we consume and sometimes overtrust what we get. So these aspects will also get probably into the API top 10. And I'm going to leave you with that important slide. We really need help. We really don't want everyone to join us. We're currently open on our website, both for opinions and also for data. If you know any API security vendor that want to contribute some data, or even big organizations that have a lot of data about their APIs, we'll be happy to get that data and try to understand more what we're doing. And also opinions from single people who are running their own APIs. This is always something that we're happy to hear. So please join us, and thank you very much. Do we have time for questions? Are there any questions?
Question. On one of the items in the top 10, the filtering problem, what do you, left here, filtering, et cetera, what do you suggest?
So this is again an architecture issue, design issue. I think that beyond the awareness of developers of the fact that you're sending something to someone does not mean that it stops there. And this is again the entire component. We're seeing here maps of 4 components. I haven't seen software with 4 components. I've seen software with thousands. We don't really know where it goes. And this is something that our developers need to understand. Most of them understand that, but while implementing something, it's sometimes easier. And it's very, very clear where it goes and that it's safe. But we never know what the next hop is. So it's a lot about education, trying not to use all this to JSON and all these methods that makes it too easy to drop. I find it also very helpful when the product managers, the PM, when they think about that. I'll give you an example. How about instead of writing in your requirements, send user information to that point, send user and password and only that to that point, or something like that. Sometimes this is all you need to remind the developer, oh yeah, I want only these 3 items to be sent. If in the future someone needs more, it's very easy to add another parameter. But rolling back after you send everything and then trying to filter that and to remove that, it's always a problem. Was that?
So what if, sometimes I get pushback saying, well, they're deciding it's a private API, it's not worth much, it's private, right? Not going to expose that across organizations or DMC.
Yeah. I hear that a lot. So we have the only thing I can tell you. I can give you two things to try and use. First of all is security in depth. I mean, yes, I know that it is secure. I want to make it secure. Is that a word? No, I want to make it more secure. I want to make sure that we have some sort of layer model. We have a layer mechanism. If something fails, we have that. This is something that's supposed to work. Another thing is that it is not going to be exposed today, but we don't know what's happening tomorrow. I'm not saying that tomorrow it's going to be public, but maybe tomorrow it's going to be for other departments in your organization, or maybe a third party or a partner or something like that. We need to remember that everything is very agile, and that's good, but the way of changing how things are open today and tomorrow, it's so easy. Again, it's a click of a button or flip of a false to true sometimes. So That's it. Also, I think that they will need to explain to you why not. It's not that hard usually, right? Unless I don't know, you're using some sort of weird flow. But theoretically, it's not supposed to be that hard to make sure that you filter things at home before you send them away. So these are the three comments I may have here. Yes, in the back.
Yeah, so what kind of surface attacks have you been seeing with GraphQL and gRPC? Has it just been sort of an excessive data leakage, or is it something more that has to do sometimes with data line?
So we're just getting into that. I think by we, I mean everyone. gRPC is mainly about data leakage, yes. GraphQL is a bit more about we can say that GraphQL being too helpful sometimes. The querying is for me as an attacker, it's very it makes me happy and cringe at the same time. But you know, from giving you the entire scope to even trying to help you, oh, I don't have that endpoint. Did you want this one instead? Yeah, thank you for that. So there is also the depth of the queries that can create a denial of service and many other things that we're looking at the moment. I'm not saying it's less secure than REST or whatever we know for ages, but remember in the first slide I said that I see that the trend is that the newer things are always the least secured ones. So this is at the moment where GraphQL and gRPC stand, I think. Yeah.
You had mentioned that errors may have too much detail, and I totally agree. But I've seen errors be really useful, you know, when you're trying to discern what is going wrong with the system. Is there a just enough kind of criteria out there?
No. If you can control yourself and you want to keep them on, you know, until you go out into production and you have a very, very clear definition or process of how to do that, sure. I never seen someone who managed to do that. Probably login should be easier to work with than nothing, but no. There should be zero extra information for an attacker. Or less than zero if you want to, you know, to push them the wrong way. We hate that. Excellent. Thank you, everyone. I'm still going to roam around. Thank you very much.